In this video, we're going to look at standardising normal distribution and what it means and why you would do it. So we know that we can transpose any normal distribution by changing its mean and its standard deviation. But what you may not be aware is we can actually take any normal distribution and transform it back into the standard normal, where the mean is 0 and the standard deviation is 1. What this allows you to do is it allows you to make comparisons between distributions with different means and different standard deviations. So to do that, what we do is we convert our x value into what we call a standard score or a z-score. So we take our x scores for our normal distribution, this one here's got a mean of 110, and we turn it into this distribution here with a mean of 0. And the standard deviation values of +1 just tell you that it is 1 standard deviation above the mean. So this point here is 1 standard deviation above the mean. It's hard to know, but when you change it into a z-score, it's very clear. So to turn an x value into a standard score or a z-score, what you do is you take that x value, you subtract the mean of the distribution that it's coming from and divide by the standard deviation of the distribution that it's coming from. Let's have a look at some. So a Year 11 student scored the following results in the Semester 1 exams. There they are down here. There's their marks. That's the mean for the paper and the standard deviation for the paper. In which subject did they do best when compared to their peers? So what we want to do is we want to be able to have some commonality where we can compare this score for methods compared to the mean and the standard deviation with this score for the chemistry compared to the mean and the standard deviation. And I know you can probably tell I've used rounded numbers, I've used integer numbers to make it easy, and you could probably say, well, 72 is above the mean, how many standard deviations? And that is literally what we're going to do with the standard score. We're going to find out how many standard deviations above or below the mean it is. So we're going to use our Z formula to calculate our standard score, to calculate our Z score. And this is a formula that you need to know. This one here is a formula that you need to know. And so we're going to create a list of standardized scores. So our Z score, we take our X value, which was the mark that they got, subtract the mean 68, divide by standard deviation 5, and we get 0.8. This means that their method score is 0.8 of a standard deviation above the mean. If we do the same with chemistry, we get 0.67, so not quite as good. For physics, 1.5, definitely their best so far. And when we do the English score, the Z score is 2, so the best performance against all of the other students is actually in English. So the standard normal curve, or the standardized normal curve, we use the letter Z. So Z, if you see a Z, it's the standard normal. So this is our mean and this is our variance. Remember, you may as well write that as 1 squared. And to change from a Z score back to change from an X value to a Z score, you subtract the mean and divide by the standard deviation. So this is what it looks like here. These are our Z scores along here. And the same rules apply, 68% within the first standard deviation, etc., etc. And as I mentioned, positive values for Z indicate that the data value was above the mean, so up here, and the negative values indicate that the data values were below the mean. Now this isn't part of your course, but this is something that you might just like to try. In the old days, all we had to use to work out any normal probability was this table of values that you see over here, the standard normal table. And what we used to have to do is, say we started out with this distribution here, we wanted to find the probability that x was greater than 12.5, then what we would need to do is, because this is a standard normal table, we would need to convert this into its z-score, and then we would look up its z-score from the probability table. Now it just so happens that I've made the z-score for this particular distribution equal to the z-score that they've got here of 1.25. Now, to read the z-score, the probability for 1.25, you can see this little coloured section of the graph. So this table is going to tell me this probability in here. And then I'm going to have to, so I'll just find this value first. So 1.25, so I start here, 1.25, so I come down to 1.2, down to 1.2 here, and then I go across until I'm underneath 0.5, and that is my value there. And that tells me that this area here is 0.3944. What I want to know is how much is this area. And so I need to use my symmetry properties. I need to use my knowledge of 68, 95, 99.7 to find the appropriate probability. For you, all you do is, in your calculator, you change the mean to 10 and the standard deviation to 2. So nowadays, pretty much the only thing that standardising a normal distribution is used for is to literally just compare values from different distributions. That's all.